Well, Madam Mayor, Cecilia Wade Brown, President John Richards, distinguished guests, ladies and gentlemen, what a most impressive opening we've had this morning. It's a wonderful reminder to us of the role of local culture and the importance of the development of our own culture in the sustainable development of the world. For me, bringing together the technologies and culture is one of the most significant things that the International Society of Digital Earth can do. In our case, we've got the challenge of harnessing this technology, and what I'd like to do this morning is to step you through how we're going to harness that technology with some examples, and I'd like to pose for you some of the challenges that we've got to meet. Can I acknowledge Richard Simpson, James Chatterley and the team, and obviously Philippa and everybody here at the Town Hall for all of the wonderful support that you've provided in setting up this conference. In preparing the presentation, Phil Tickle and Nathan Quadros, and to the International Society of Digital Earth for making these absolutely vital conversations possible. So I'm going to look just to rehash some of the significant global challenges that we've got before us, the role of the cutting edge technologies, and I want to finish with a few key messages. Now, some of this is self-evident, but it's worth reminding ourselves of. The world is warming. You can see from three distinguished sources here that there has been a significant and measurable increase in the temperature of the Earth, the average temperature of the Earth. And you can see that it's particularly clustered in the northern climes and right down to the south. Australia and New Zealand are not as seriously affected as those northern areas, but nevertheless, all of the world is facing an increase. Despite the fact that Australia is not suffering the worst, there have been a significant increase in the number of hot days and a decrease in the number of cold days, as we can see from the top graph and the bottom graph. Average global sea levels have been rising since 1850. And in recent years, we've been using not just in situ data, but satellite data to tell us about this rise. We can project forward what sea level rise might look like over the next 100 years, depending on how we, as a human species, choose to manage the issues before us. And the projections are all significant, and some of them are much more significant than the others. And then there's atmospheric CO2. In this case, we're looking at a baseline of 2,000 years, established from CO2 ice core monitoring. And just look at the right-hand side of that graph, really in the last 70 or 80 years. An exponential, or probably greater than exponential, increase in atmospheric CO2. And then we can establish relationships between CO2 increases and global warming. We can also forecast what might happen if we can do something about that CO2. Now these developments have consequences. Just one of the consequences is on the world's water security. So 80% of the world's population lives in areas where the threat of water security is significant. And you can see that band through the middle part of the world that's most seriously affected. We now know these things as a world. Here we have an indication of the per capita, that's per person, emissions by country. Number one is Australia, regrettably. And as we go down through the list, you can see the other high emitting nations. This was reproduced in a report by Australia's Climate Commission just last month. So Australia is being reminded of the significant contribution we are making just as we introduce an emissions trading scheme into Australia. So we've started to do something about it. There are technologies that are helping us understand the digital Earth consequences. Now, of course, we've got some technologies already in that prior information that I've presented, but let me share with you some others. This is the Sendai, Japan earthquake of 11 March last year. We're going to see the impact of the earthquake on the base stations, the GPS base stations, in the moments before, during and after the earthquake here. Now, Japan has got many hundreds of these base stations, and these graphs represent on the left-hand side the horizontal displacement. That is the movement in Japan as a result of the earthquake. Let's run it again. A few seconds before, now we're going into it. You'll see that Japan has permanently moved to the right and sunk in areas and gone up in areas. Now, base stations are typically used for mobile monitoring, traffic control, navigation and so on. But in this case, we're starting to get to use them for process modelling of a whole nation. It's the sort of information we can start to harness to get a better understanding of our global Earth. Here's a tool closer to home. The governments of Australia 4 years ago collectively agreed that they wanted to understand the consequences of the impact of sea level rise in Australia. As a result, they initiated a project called the Urban DEM project and invested $8 million creating very high resolution digital elevation models based on 15 centimetre LiDAR data over the 80% of Australia which is built up, so coastal Australia. And the data that I'm showing here shows the sea level rise tool operating over an area just outside of Brisbane on the east coast. It shows the houses that would be affected by a sea level rise of up to 1.6 metres, but at about 40 centimetres we're starting to get significant impacts on houses. It also shows property boundaries, and you can see on the left-hand side there's a whole range of other information that people can get access to understand the consequences on them. A 15 centimetre vertical resolution DEM gives anybody the opportunity to identify where the sea level rise will occur right to their back doorstep. You could work out which houses you sandbag and which ones you don't. There's a vast amount of information associated with this, and it's not possible to stream that information down to end users. So this tool, this visualisation tool, designed to educate the public, is being implemented via a registration system. At the moment, the governments of Australia are taking federal, state, local governments only, and there are 350 registered users. There's about 700 governments across Australia, but in time, it's intended to take it public. However, there's a series of static maps which are available, and so far, we've downloaded 300,000 of those maps, and the website for them is getting between 10,000 and 40,000 hits per month. This is significant because if we want to develop a three-dimensional model in digital Earth, we're going to need very high resolution digital elevation models to describe the surface of the Earth. Once we've got that, it unlocks a whole range of additional applications that we haven't only just begun to understand. Global navigation satellite technologies are about to explode. So we've got GPS at the moment. There are 5 additional systems going up around the world. Japan, Russia, India, China, European Union are all putting systems up. And what this graph is showing is the concentration of satellites that we'll be able to see. So typically we can see maybe 4 or 5, perhaps 6 on a good day, provided they're above the horizon and aren't occluded by any physical objects. What this is saying is that we're going to be able to see up to 50 satellites, and particularly in the Australia, Southeast Asia, Pacific region. Other areas will also benefit. In Australia's case, we're looking to harness all of those signals to develop a 2 centimetre positioning accuracy offered via a single solution, just a network solution, for any Australian outdoors. Now we know from our economic modelling that we can add many billions of dollars to the construction, mining and transport industries alone in Australia, but we can do even more with this across all of the locational services which are now starting to open up. So this is a very significant development, not just for our part of the world, but for the whole world. Positioning systems are not just growing in terms of their number, but they're growing in terms of their applications. And here's a few statistics about how significant the developments are. So 80% of mobile phones, for example, being sold this year will have a positioning device in them. We're seeing significant increases in revenue, mobile search. We're seeing that consumers are prepared to have others know where they are, so that that information can be used for other purposes. Fortunately, the US government is continuing to make a significant investment in GPS, and we've got the other governments as well. And I've already mentioned the fact that we're going to see 5 additional systems. So Skyhook, a significant magazine in this area, has indicated that location is going to be the next big thing in mobile technologies. And there's a range of technologies that I've listed there that are now available via mobile phones and other devices. We're not going to just see a single solution, and particularly indoors, we're going to be looking at a variety of solutions. And they will be available within the next 5 years for everybody. Remote sensing is also witnessing very significant developments. There are 40 nations in space. There are 160 active imaging satellites at the moment. And that number is set to double over the next 10 years. And we're going to see a whole range of new satellites coming forward. Despite the depressed global situation at the moment economically, there are projected to be significant growth in the remote sensing markets. There are 40 countries that are proposing to launch additional satellites, and with the development of cube satellites and microsatellites, satellites that are around 20 kilograms in weight, the prospect of a country getting access to and being able to afford a satellite has gone up substantially. There's recruiting, significant recruiting taking place. We've also got UAVs coming forward as platforms, and interestingly, in the United States, there are 6 states that are introducing autonomous, driverless legislation, harnessing positioning information, UAV kind of technologies on the ground, to enable us to enter a whole new era. I like this next one that I'm about to show you, because it gives you some idea of the significant infrastructure that we are responsible for putting into space. So 13,000 satellites. That includes a lot of decommissioned satellites, space junk, as we would know it, that are being tracked by NASA and other agencies. It also includes the communication satellites, the relay satellites and the positioning satellites. There's a significant amount of space infrastructure which is contributing to our digital Earth. In a GIS sense, we're also witnessing significant growth. Jack Dangermond has told us that there are parts of the markets that are growing at between 35% and 100%. We've seen significant and sustained growth in GIS over the last 8 years. And the health side of geospatial is foreshadowed to be the single fastest growing around the world. That's very interesting because world growth is averaging around 3 to 3.5%, but the spatial technologies are witnessing growth at least 3 times that. So there is something obviously very significant about them. Let's turn to the web. Now here's a graph which is showing us the evolution of the components of the web. And on it, I've marked where the SDIs are now. Over the last 6 months, Australia and New Zealand have completed a study of 34 of the leading spatial data infrastructures, identifying the state of development of them, their level of maturity, looking at the overlaps between them and at the uniqueness. We've identified that in fact there are a great deal of common elements about them. They're not all well being coordinated at the moment, but there's an opportunity to bring them much closer together to unlock synergies in a combined approach. This is where SDIs are foreshadowed to be in 5 years' time. And in doing that, they enter the realm of the semantic web, the intelligent web, the cyber web. Why is that significant for us? It gives us enormously more potential to do smart things with our basic information. What I've got here is Tim Berners-Lee web stack, which shows the basic building blocks of web-based information and technologies going all the way through to the end users. Let's just focus on the bottom line for a moment. What the Unicodes are telling us is that there's a standard for consistent encoding that we can establish so that there is complete interoperability across the web. URIs give us the opportunity to uniquely identify the location and type of every point, line and polygon, every piece of information in the web. The next line above gives us the ability to introduce languages that are both machine readable and human readable. They're an interface language. And that's significant for us because no longer will we be in the domain of the few black box specialists who do the coding on the web, but in plain language, we're going to be able to access web resources. There'll be a metadata schema that will be available to all, and there'll be a series of relationships that will be established right across the data that will be built by the ontologies. Ontologies are a mechanism for understanding both the meaning and the relationship between information on the web as used in the sense of the semantic web. This is a complex web model which we use in Australia for our addressing systems. This has been built by hand, and it's just to try and understand how we can get to a single, unique and agreed street address and postal address in Australia. That's a simple one. And what we're facing around the world are vastly more complex models than this. We won't have the ability to prepare them by hand. We're going to have to do it using the semantic web, and the semantic web gives us the power to do that. So in Australia, all of the governments of Australia have agreed in recent months to establish a program which will move all of our government-held SDIs into a semantic web environment. Now, we're probably talking a 10-year migration for that, but at least we've got commonality of agreement amongst all of those governments. New Zealand are a partner in this, and they've agreed to do this as well. So there's a joint relationship that's proving to be very successful for both nations. In addition to that, the governments of Australia have agreed to establish, and New Zealand have agreed to establish, a spatial marketplace. That is quite simply a place where you can go to get access to any map-based spatial resource, whether it's a data set, an application, information about data, and to do so in an open systems, open architecture mode. The intention is to make this information as widely available as possible. Now, this will be underpinned by the semantic web. And so this is going to cause a revolution in the way in which information is going to be made available. There'll be more on this immediately after lunch when Denise McKenzie, one of the managers of the Spatial Marketplace, will be speaking specifically about this topic. But there's much more to it than that, of course. To make the most of all of this vastly expanding wealth of information, we're going to be harnessing a whole range of converging technologies. What I'm showing here essentially came out of the Perth Symposium last year. And it coalesced a series of thoughts that were coming from a variety of sources. But we're going to be looking at a series of powerfully converging technologies, not just the obvious candidates like positioning and remote sensing, but we'll be looking at simulation, optimisation, augmented reality, the gaming technologies. We could go on. Now, as they come together, our ability to make more sense of a digital Earth vastly improves. Because if digital Earth is the representation in a virtual sense of the real world, to be able to do that, we're going to need to harness these technologies. It's not sufficient to have one operating on its own. And this is building digital Earth. And tomorrow, the Chief Executive of Virtual Australia and New Zealand, another initiative that the two nations have established, Michael Haynes, will be talking to us specifically about this one. So there are significant drivers in this area. Automation, it's going to save a great deal of human-induced effort. We'll be moving to real-time information. The virtual world becomes more of a reality for us. There'll be real-time modelling, and that'll be particularly significant for disasters and emergency response. And augmented reality, and we're going to see some examples of that over the next couple of days, will also become a powerful additional tool. And Mike Goodchild recently, in fact at the GSDI conference in his summation speech, posed to the audience a paradigm shift in the way we should think about these things. From place-based GIS, which is geographic coordinate-based GIS, to place-based GIS from coordinate GIS, to move to placial technology rather than spatial technology. And the revolution in location-based services presages that development. So my key messages for us are these. We are, in disparate bit-by-bit ways, building elements of the real world. We're starting to put real power into them, so not just videos, but we're building process models, time-stamped. They'll have metrics so we can analyse them. They'll have topology, so every point, line and polygon will know its place and know what its neighbours are. And there'll be lots of additional thematic information that we can also tag with spatial information. This is a complex task, and that's an understatement. There are many that don't understand digital Earth, and if you don't understand it, you can't make full use of its potential. And the ability to get better coordination and collaboration is very difficult across this space, but we have to find a way to unlock the benefits sooner. These sorts of conversations and the role of the International Society of Digital Earth is one of the leading mechanisms for being able to do that globally. And if we can, we'll make a greater ability of these technologies to tackle these issues, from the environmental to the economic to the social. Now I'm going to finish with this picture here. The interconnectedness of the world. You can see where China is. China's not showing on this one, but Weibo, I'm sure, would have the same intensity within China. I'm not quite sure what to make of this. It's a very pretty picture. It certainly indicates a connectedness around the world. This is all part of Digital Earth too, and this is something we have to harness. Thank you.